In December, the James Webb Telescope, which is about 1 million miles out there, right, in one of the Lagrange points, confirmed the universe is expanding at an unexpectedly fast rate. Why is it unexpectedly fast, and why does it matter?
Well, it matters. I mean, you're right. In some sense, it doesn't matter, but it matters in the future. So the universe is expanding, and we found out a few decades ago that it's accelerating in its expansion. So it's expanding faster and faster.
Do we know why?
We don't really know why. So in astronomy, if you don't know what something is, you just put dark in front of it. So we call it dark energy. So there's something called dark energy which dominates the universe. That's 3/4 of the energy in the universe or so.
And you know that it's there? Is it measurable?
We know it's there because we measure that the galaxies are moving apart from each other faster and faster. So you can make that measurement. And then you infer, therefore, that something has got to be stretching space faster than we expected.
So wait, let me ask, hold on. Space, stretching
does that sound a bit complicated?
Space feels a little weird because, okay, so you have all these galaxies. Let's just say these galaxies, all the galaxies in the world were in a 1 by 1 by 1 cube, like 1 foot by 1 foot by 1 foot cube. And if I pulled the cube like this and made the space of the cube bigger, and the galaxies sort of stay in the sort of gelatinous material of space that's inside of it and move with the sides of the walls as I pull them out, so they spread apart from each other. Are they really expanding, or are they just changing their position relative to each other because the space that they occupy is growing further apart?
It's a great question. So we're talking about Einstein's theory of general relativity. It's 1915, this theory. And that's a theory of something called space-time. So it's often called the fabric of the universe. So immediately there you can see this idea that space and time are kind of woven together into a fabric. And the idea really is that that fabric stretches. And you know, the first person to suspect that from the mathematics, because you were talking about the Pope earlier, was a priest, a Catholic priest called Georges Lemaitre. And he was the first to take the theory seriously. And and you imagine he saw it in the equations, this tendency for the space to stretch. So he reasoned, well, then that means that everything was closer together in the past. And he wrote a very famous letter to Einstein and said, your theory suggests there was a day without a yesterday. Because he was imagining, just from the mathematics, he was imagining this time when everything
well, that's
may have
essentially
begun.
the Big Bang, right?
Yeah.
So he came up with the idea of the Big Bang.
Yeah, so he's often called the father of the Big Bang. And he was once asked, I was thinking when you were in the interview earlier, he was once asked, how can you be a priest and a physicist and a mathematician and do all this cosmology? He said, there are 2 roads to the truth and I choose to take them both. Which is a very beautiful answer, isn't it? It's a very poetic man.